Welcome to CIC Start Online webinar. My name is Branka Dimitrijević and I will moderate today's event. Our seminars and webinars disseminate outcomes of feasibility studies and academic consultancies undertaken through our project, and also the outcomes of research undertaken at the universities involved in CIC Start Online project. The project supports collaboration between Scottish universities and small to medium-sized enterprises in developing and testing innovations for sustainable building design and refurbishment. The project is funded by European Regional Development Fund and a CIC program of Scottish Government, which is now managed by Scottish Funding Council. This is a live event, and if there is a fire alarm, we will have to stop and we will continue later, and you are welcome to join us. But if you cannot, you can always watch a video recording of this webinar, which will be published in a day or two. We plan to finish the presentations around 1:30, and there will be opportunity to ask questions. You can start using chat facility immediately during the presentation. And the event will close around 2 o'clock. So the title of today's webinar is Outdoor Comfort and Urban Heat Island Studies in Glasgow. This presentation shows a summary of studies conducted in 2011 in Glasgow, and they are related to thermal perception of pedestrians and to the observed heat island effect in its urban area. Our speakers today are Professor Dr. Eduardo Krüger, Associate Professor at Department of Civil Engineering at Technological University of Paraná in Brazil, and Dr. Rohinton Emmanuel, a reader in Sustainable Design in Construction at Glasgow Caledonian University. I would kindly ask you now, Rohinton, to give us introduction to the webinar.
Thank you, Branka. Welcome to the webinar on urban heat island and pedestrian comfort in Glasgow. This is a result of work that we've done most of last year, including establishment of weather stations in and around the city of Glasgow, questionnaire surveys of pedestrians in the pedestrianized areas of Glasgow, plus some modeling studies that we have done. Results are beginning to be published in many of the journals, including Building and Environment, Theoretical and Applied Climatology, and International Journal of Biometeorology. The work is partly funded by the Technological University of Paraná and Glasgow Caledonian University. We wish to acknowledge the contributions made by our two institutions in making this possible. And if I could start by talking about the background to this work. So we would initially we would talk about the some of the aims and objectives of the work, and then Eduardo would then present the method and early results. And as I said, many of it are already included in the or published in international journals. Next one, please. So it is it was quite unusual for us to start talking about urban heat island in a cold climate city such as Glasgow. But given the warming trends globally and even regionally, this is increasingly a problem, even in cold climate cities. But worldwide, urban heat island is a larger problem. It currently is estimated the magnitude of change in climate in cities caused by local warming is at least as big as the global warming effect. Half of the population are now living in cities, and much of that urban growth of course, is in the tropics, many of which are in the warm, humid areas. But cities themselves only occupy a tiny portion of the land area. Today, they are estimated to be occupying about 3% or less than 3% of global land coverage. Yet, in the coming decades, it is possible that the growth in exponential growth in cities could lead to larger changes not only within the cities but regionally and even globally. Here in this image, you can see some of the regional changes brought about by urban growth. On the left, you would see an image of daytime, but on the other side, you would see also the relationship between the rate of warming between rural and urban areas. And you would recognize in the image many of the urban centers of Southeast Asia in this case. The images are similar. Wherever you pick it, the cities appear as a warm patch in cool surroundings, hence the term urban heat island. And they exist in all parts of the world, including in very cold climates. And of course, they are a bigger problem in warmer climates. The links are important. I think as the world begins to start talking about and moving towards a low carbon economy, a low carbon global economy, and attempting to legislate and develop policies to reduce human impact on global climate change. There are two problems that are associated in here. One is that the nature of change and its lag time is such that we need to do something to adapt our cities and human habitations today. And that's where I think urban heat island and its adaptation is a key role to play. It is also a long-term mitigation possibility, since most people will now live in cities or already now live in cities. Most people will experience climate change also in cities. So it is important that we adapt as well as mitigate the negative consequences of climate change in cities first, because that will then benefit a larger portion of humanity. The other is, of course, the rapid land cover changes. The changes that we have seen are quite large, but it is nothing like what we will see in the coming decades. And therefore, it is only natural to expect the changes to be more rapid in the coming decades and perhaps the rest of this century. So and given the fact cities take a very long time to change, urban policies are notoriously slow, it is important that we start to design cities to take care of the overheating, microclimatic change now, so that they are ready in the coming decades. So our work was to attempt to establish the picture in Glasgow and to put Glasgow's urban climate on the map of global studies on urban climate change. This, as I said beginning, we collaborated with Technological University of Paraná in this, and it is now continuing. Our work is now being picked up by the local authorities, overheating problem analysis for the Glasgow Clyde Valley region, and so forth. The work here that we are going to present today itself is about the thermal comfort studies as well as the heat island studies that we done. We have established weather stations around the city and compared and contrasted the local changes over and above the background changes that are occurring in the city. And the ultimate aim of this is to try and influence urban planning to improve the predictability and the ability to change local warming in the positive direction. Of course, initially, urban heat island effect in Glasgow is a positive thing because we can benefit from the warmth. But over time, it will be a problem leading to overheating. So we are trying to see both the positive and the negative aspects. Next, please. now my colleague Eduardo would start talking about the actual methods that we used and the early findings.
I'll discuss here the methods that we use for several studies. As Rohinton said, we conducted the surveys on outdoor comfort and also a UHI study on using a network of stations around the city. Apart from that, we carried out some traverse measurements with a bicycle, and also we finished with the thermal simulations of the urban area, central area of Glasgow. For each of those studies, we had a different method of analysis and data gathering. So in the case of the surveys, we considered the pedestrian zone between Buchanan and Argyle Street and Sauchiehall Hall, and we had a weather station. As you can see in this image, there's a weather station, and it had temperature and humidity sensors, a pyranometer to record the global radiation, solar radiation. We had a wind vane with anemometer to record also wind speed and wind direction. And we had a globe thermometer so that we had an idea of the radiant heat emitted by the surfaces. Those measurements, they took place between March and July, and during the time of the measurements, we had the outdoor survey campaigns, and we on 19 days in total, we interviewed about 750 people. The monitoring points you can see in this image, they were chosen because they have different characteristics. Each one had a different view factor. So they have different exposure to solar radiation. They have a different shape of buildings around. And for each of those points, we had a similar number of people being interviewed. And for the sake of comparisons, we wanted to compare the results that we get in one place to a reference station. We established a reference station at GCU. So there was a weather station which was placed on top of the Saltire Center, which is a building not very high. It's a low-rise building, and the weather station is still active today. The comfort questionnaire was based on ISO 10551. It's a basic questionnaire, and we had some general questions on the person that we interviewed at first, and then we had 2 questions on the thermal sensation and thermal preference, and this was compared to the climate data that we gathered with the weather station. For the UHI study, the Urban Heat Island study, we had a set of stations. They were placed in the north-south transect, starting from the university there. One station was at the Macintosh School of Architecture, and then we had another one in the central area, downtown Glasgow. Another station was in Glasgow Green. It was green area, an urban park, and 3 residential areas. And you can see the surroundings of each station in this picture. They had also different view factors. Those pictures, they're made with a special camera with a fisheye lens. You take the picture facing the zenith, and then you can get an idea of how obstructed is the site by converting the image to a certain value. And this value gives you the idea how much exposed you are, and how much sun you get, and how much heat will be absorbed by the surfaces. For the urban heat island study, we had also two stations. One station was central, the Glasgow Caledonian station, the reference station, and we had another station was installed outside the urban area at Cocknell Farm. It's an experimental farm run by the University of Glasgow, and so these two stations, they allowed us to compare the urban heat island effect on different in different days and different under different atmospheric conditions. The traverse measurements, they were carried out with a bicycle. I divide some kind of gadget with a fan, mini fan, and a tiny tag data logger, and I attached this to the frame of my bicycle, and I conducted a series of traverse measurements with the bicycle within 2 hours. And you can see here the pictures. They also show the sky view factors of different points, and in total I had 20 monitoring points. And the simulations, this was perhaps the last step of measurements and analysis that we carried out. They were run with an urban climate tool called EnviMat. And there you can create a 3D model of the urban area, and you can run simulations of the climate, considering the 3D aspect of the buildings and the input data, climate data. And in the end, you get a graph like this, like in the right hand side of the building here, where you can see the temperatures in different locations, different areas within a certain region. And as for the outcomes here, I tried to summarize the outcomes in 4 or 5 main outcomes. At first, we used the survey data, the preference, thermal preference and thermal sensations, to compare with established thermal comfort models. Here's a collaboration also with a researcher from IFADO. This is an institute based in Germany, and during the survey, after I had the results, I had the chance of going to Germany for 1 week and to work with the data with this thermal model. It's called UTCI. This is the Universal Thermal Climate Index, and the comparison was with the UTCI predictions and also with the data that I had from Brazil. So I can have a different perspective when we look at the graph on the right-hand side, and you can see that the thermal preference changes depending on whether you're here in Glasgow or in Curitiba in Brazil, where it's a subtropical place, location, and you see the thermal preference and sensation changes according to local climate. This is very, very important also to calibrate such indices. One step was to look at those established comfort indices and try to calibrate them to the local conditions. On the left-hand side, you can see one very known thermal index used for outdoor studies, which is called PET. It's physiological equivalent temperature, and this is being used in several studies in outdoor comfort. And you can see the gray area. This is the comfort area, the comfort region, and we had a few points which lie within this region. So from there you can establish a range of comfortable conditions, and what lies below this range could be regarded as cold conditions, and what lies above this region could be regarded as hot conditions, warm conditions. So using those tools or those calibrated tools, you can use the indices for one graph is not being showed here, but using those calibrated indices, you can have an idea or can improve, you can optimize UHI analysis by adding the expected thermal comfort conditions or discomfort conditions in a certain area. This is very important, very relevant for, as a, let's say, an addition to the standard UHI analysis. The conventional UHI analysis is based on the temperature differences between the rural and the urban location. So you compare both and you see which parts of the day you have a higher temperature within the city or outside the city, and you can conclude something on the urbanization aspects and how the urbanized area will have an effect on urban microclimate. Apart from that, using our network, we could try to establish some relationships between a given location and the difference to a reference station or to the mean value. If you take the mean from all points measured. In the next slide, you can see in the graph below. This is an in-depth analysis for the several days that we had those measurements running. We were able to categorize them according to atmospheric stability aspects. You can see there in the bottom that for each location, a different temperature difference is observed. So for each condition, atmospheric condition, you can have different responses in terms of urban climate, in terms of the local climate. And this is very important because if we only take measurements and take the overall difference as a certain response, that may not be the truth. Maybe we should look at the clear sky conditions and stability, atmospheric stability. So looking at the results of the urban heat island study, here are the different categories. We have the in this table we have the all data, all files from 7 or 8 months of measurements, and then we have the cold period and the warm period, and then I have a series of days, and they have a different kind of response, different kind of atmospheric stability class. And the most relevant differences, they are observed for the clear sky conditions on a particular day type. That means if you disconsider all possible atmospheric influences and you look only at the urban aspects or the urban form as the main causation of the local temperature, under such conditions we can reach up to 5 or 6 degrees at night, the maximum temperature difference, which is very more much more important than 3.1 considering all data. And so I have to say something about the difficulties and limitations of the study. And one of these, so I'll concentrate on the 3 main studies that we conducted. During the surveys, I have to say something about the local accent. So I had some problems of understanding people who would stop for us, and also another problem. This is a common issue in such studies, is the willingness of the participants. because for outdoor comfort studies, usually you have to stop people and you have to have people who are willing to give you answers. And sometimes they are not really helpful enough to give us some answers. The other thing about the outdoor comfort study is that we wanted to carry out those studies during clear sky conditions, and at least that it was sunny day or a pleasant day to be outside. So data was mostly concentrated on warmer conditions. The winter was a bit wet last year. So we started in March and it went until July. So the bulk of the data was concentrated on warmer conditions. The UHI study, despite of some gaps in the data series, we had a fairly consistent response. The results, they were very, very consistent. But even then, there was no clear relationship between urban form and local microclimate. Perhaps this could be a result of the more uniform pattern in urban morphology. I was saying something about the sky view factors, the sky view perspectives in certain locations, and they tend to be very, very similar. There was not a huge difference between locations. That could have influenced the results. And as for the traverse measurements on the bicycle, the results indicated not a very clear pattern, and this could be a problem during because of the few days that we conducted the traverse measurements. There were only a few occasions that I could do this, and again, there was no clear relationship between the morphology and the local temperature. Maybe these traverse measurements could be carried out in the future for Glasgow. The publications that arose from these studies, there are more publications which are under preparation presently, but we managed to get something published during this year, and next week we will be presenting some outcomes during the Urban Climate Conference in Dublin. Okay, thank you for listening. If there are any questions.
Thank you very much for your presentation. Well, we could start with some basic questions about methodology. And, for example, why is information collected through surveys on thermal comfort important? Why did you do that? What does it tell you? How can people can help you to understand better the problem of urban heat island?
This is a question that many people would ask us when we stop them to interview them. So this is a common question. Why are you doing this? Why are you asking us about our thermal sensation and thermal preference? Why is this relevant? The importance of this, as I showed you, is to calibrate comfort indices for the location. So if you're doing something here in Glasgow, I have to know what region would be comfortable according to local preferences. So we have to adapt what is general. Those comfort indices, they are general, and the comfort index integrates different variables. So you have temperature, wind speed, and humidity, and solar radiation. They're integrated into one single value, and it's important to have this value adapted to the local conditions. So I can have a range, and using this range, I can know I can use this as a calibrated tool to conclude something on whether it's too hot or too cold, depending on the present conditions.
Yes, I think also to add that is an important point to validate and calibrate to Glasgow. I think. For example, Eduardo showed in one of the slides the range that is considered comfortable in Glasgow is in the index called PET, physiological equivalent temperature. It is 9 to 18 degrees. It's not 9 to 18 degrees temperature, but 9 to 18 degrees in PET. Whereas most cities, most climates, the lowest comfort range is 18, and it is 18 to 23. In other words, Glaswegians are adapted to a lower climate, even though they complain it is not comfortable, but they are adapted to a lower range, which is important in the context of regional warming. Now, we are taking this further in the next stages. In 20 years' time, 25 years' time, Glasgow's climate is supposed to be very close to London's climate today, which will then mean we will have a huge overheating problem. And we need to start designing buildings today that will be able to withstand this coming onslaught of overheating. So we need to know what is overheating, which is, it might look rather amusing to people from a warmer climate that a fairly low temperature is considered overheating here, but that is the reality. This is the adapted reality. So this is an evidence base for climate change adaptation in coming years, I think.
But could we also think that people will adapt, that new generation faced with new climate conditions will then appreciate warmer climate and would not say, well, that 9 degrees is acceptable, but maybe 15, 16?
Yes, yes, of course. They will also, I think, in the end, I think, as long as we begin to live in warmer climates, and once we have an experience of warmer winters, warmer summers, people will eventually, initially they will die, they will have diseases, they will have morbidity, but over a period of time they will adapt. That has happened in other cities, will happen. However, we have to plan for this. It is something that in order to get there, the path is not necessarily pleasant. We have seen this in 2003, the major heat wave in London, in Wales, especially in France, in Paris. Over 10,000 people died. And that will happen many times over in the coming years. So we need to know at what temperature that we need to take our, warn our stakeholders that this is getting to a point of problematic area. But obviously, over a period of time, that temperature itself will rise. Eventually, we will be comfortable at current London temperature, but maybe it will take some time. Yes.
There is a general question from Tony Cowling of Tony's House. Isn't heat island an effect that we'll always get in big cities with or without climate change?
That's right. Yes, obviously. This is very important also. I think in the initial stages of climate change debate, a lot of people said part of the climate change is urban heat island effect, because we have traditionally measured temperature in human habitations, not in the middle of non-human habited areas. Yes, human habitation historically, ever since Vitruvius wrote his 10 books on architecture, for 2,000 years or more, people have known human settlements will create their own climate. However, this combined with global climate change is a problem, a huge problem, even in a cold climate city like Glasgow. I think that is important that we need to take care of that. The other reason I think why we study heat island is that the heat island effect itself can be controlled by planning regulations, planning adaptive strategies. Whereas global climate change, you would have seen how difficult it is to get agreement for different countries and different governments to get together to agree to tackle it. Urban heat island, it appears, is within the control of the city, so it is a bit easier for us to adapt to.
Another question from Nick Taylor of Nick Taylor Energy Consulting. As humans are easily influenced by media speculation about climate change, have you done or considered doing studies on animals, maybe farm animals, to see how they react to different climate regimes?
Never did it.
No, we have not considered this, but that would be, well, so far our interest has been on human influence on or human expectations of thermal comfort. I think we recognize, especially the problem of outdoor climate, we recognize the importance of thermal expectation. And we agree that is a problem. There's human beings are always a problem. That is, we got to design cities and outdoor spaces for human comfort. And unfortunately, the physical attributes of the cities can only explain very small part of the human comfort condition. Psychology, expectation, thermal history, all of this plays a huge part.
It's very difficult, yes.
Yes.
And since it's very difficult to interview people to get a true response, to conduct this with animals would be a very big task. I've seen some works done with animals with regard to productivity, how much milk they produce or how much eggs they lay, this kind of thing. But it's very difficult to establish a comfort range or something like that for animals.
I noticed in your measurement methods that you measure temperature from 10 to 1 o'clock
Yes,
why didn't you measure in the afternoon when we would expect that the temperature is higher?
It's higher, yeah. We try to get as many people as possible. So during lunchtime, you get more people out on the streets. So that's why we chose this period of time, and also because this is the daytime conditions that we had in Brazil in a previous study. So I wish to compare both studies. So I tried to set the same range of time. I could have extended this, but then we had a problem of the persons involved. Was me, my wife helped me out in several occasions. There was another student, PhD student, George, was also very active in interviewing people. And lately we had a guest from Brazil, Patricia. She was coming from the University of Rio de Janeiro, and she helped us during the summer measurements. And because we had only a few people involved, we couldn't extend this for 5 or 6 hours. It would be very tiring. So 3 hours would be okay, and that's what we could do.
You said that the morphology, urban morphology of Glasgow is quite consistent, and that's probably the reason why there were no variations in measurements. What was the experience in Brazil? What type of city, what type of urban morphology you had there to work with, and did you notice larger variations in the results, in the measurements? And
Yes.
could you correlate the urban morphology and the measurements?
We let's say we had a better response, a better correlation. It wasn't optimal. It wasn't something like 0.8 or 0.9, but it was higher than here. And the morphology in Brazil, and the difference between Brazil and here, is that in Brazil it's not. Although Curitiba is a different place. It's an organized urban planning, and they try to establish some heights and distances and everything. But the urban center, the downtown area where we took measurements, it's very it's not uniform. You have high-rise buildings next to low-rise buildings. It's not very well organized. So it was also a bit difficult to establish a correlation because of the difference in shape of the buildings. If we had very uniform conditions, such as here in Glasgow, but with more variations in terms of the height of the buildings to the width of the streets, then we could establish perhaps better correlations.
Having said that, I think we did find quite a strong relationship between local climate zones, what is called the local climate zone, which is essentially morphology. How high the buildings are, how dense the built environment is, what's the fraction of greenery and so forth, and temperature change. In fact, we have established an equation, not a very strong one, but an equation, which we are now using in our overheating studies in the Glasgow Clyde Valley region. We know a given morphological condition will lead to given temperature change, which then can be used in climate change studies as well.
So I think the listeners should refer to the paper in Building and Environment. It's been shown here in one of the slides.
Do you think that green roofs and green facades could mitigate urban heat island effects in cities?
Yes, vegetation plays some role in this case, and I have seen some struggles of integrating vegetation and plants to the to urban geometry, to buildings, and I think it's could have a very positive effect. And sometimes it's not very clear whether it will contribute or even worsen the conditions because of the reflectivity of the vegetation. If you're not if you don't conduct the integration of vegetation well enough, I've seen cases where you have a system of integrated vegetation integrated to a facade, and there's no system which wets the plants. So if you have a problem of the plants getting dry over time, so the benefits of the system is not fully used, and then you can have a problem.
We are currently using in the contributing to the overheating analysis for the Glasgow Clyde Valley Green Network Partnership. The idea is to simulate what effect green infrastructure will have in reducing overheating. Green infrastructure as in vegetation infrastructure, not sustainable infrastructure. So it's green roofs, green walls, trees, and so forth. So we want to see in the coming years, when the climate warms to London's levels, what effect will current green infrastructure will have in the future years. So hopefully, as I think what Eduardo said is also important. It is important to plan this green infrastructure properly, irrigate them, place them in the right places.
Yes.
They could be in the wrong place, contributing to overheating. But in the right conditions, in the right places, they could contribute to reducing the heat island.
And what other methods, especially in urban planning, urban design, could be used to mitigate this effect of urban heat islands?
Generally, the literature talks of 4 or 5 effects which the planners themselves can control. One is the sort of plot ratio, how high and how dense we allow buildings to come up. In city centers, in warmer climates, we would need some kind of a shading effect. So we would want to promote a higher density without compromising air quality, of course. We have to make sure that that happens. So density is a key part of it. Materials, thermal properties of building materials is key. What materials we allow public buildings to face, urban spaces is key, and the color. Green infrastructure, the amount of vegetation that the planners that can control. Also water could also be an element that could control the warming effects of it. I think ultimately this is linked to air quality. If we can reduce the amount of mechanized transportation, which then reduces the pollution levels, can also contribute to a better heat island mitigation. So there is a link between pedestrianization, densification is also pedestrianization, all of this to heat island mitigation also.
What can we also learn from traditional cities in hot climates, for example, in Italy, in Middle East? In Italy, they use a lot of arcades, so people walk in shade and they are protected from sunshine. So should we also promote and emphasize design aspects of buildings that mitigate this effect of heat island, urban heat island?
That's right. I mean, I think in traditional urban planning, is the promotion of sun access is what urban planning is about. That comes from sort of a bad experience in Middle Ages of darkness and industrial revolution and the pollution. Whereas in warmer climate, as the world warms, we need more shading. We need the exact opposite of what the solar access movement is promoting. It's a solar restriction. So we would need arcades, we would need pedestrian paths that are shaded. We would need different kinds of shading arrangements at different times, because the city's patterns of activities are different. At night, you don't need shading, so you could be much more open. So arcades and adjustable awnings, perhaps, could be drawn back as they do in the Middle East and southern Italy and so forth. And that kind of architecture or even urban design.
In some cases, the water bodies they're also very important. In arid zones, that you have water bodies, and maybe you have a fountain, or you have a reservoir, a pond or something. They can mitigate also the thermal discomfort during daytime.
As Brazil has much warmer climate than
Yes.
Scotland,
Yeah.
what are the methods and experiences in mitigating the effects of heat? And
Yes, in Brazil, several studies they work using vegetation. They consider using vegetation for mitigating urban heat island effect. And I've seen some studies in São Paulo where it's a bit warmer than where I live, and they are very concentrated on the use of vegetation. In the central area, in the midlands of São Paulo state, where it's a bit dry, it's not exactly arid, but it's drier than São Paulo. There are some studies now being carried out on the effect of water bodies. There's a work by Lea Cristina, and she's doing something on the effect of reservoirs, large reservoirs, and the effect on the local climate on both sides of the. It's a very interesting work. It's under development.
here is a question from Dave Tremlin of Conservation General Services. Are there plans for study on the consequences, if any, of the mitigation of the heat island effect on the microclimate of surrounding areas?
That the kind of mitigation that we are after are at the neighborhood or smaller street level. So with the expectation that the effects will not go much beyond the immediate surrounding. Our idea is to make pedestrians and the building energy consumption less. So I would expect the proposals that we come up with will not have negative consequences on the rural areas. Now, having said that, I think initially in a cold climate city like Glasgow, as we study this, initial stages, urban heat island is a good effect because it is creating warmth locally, which makes, for example, snow clearing in the city a less onerous task as opposed to the rural areas. So initially we should also try to promote the heat island effect to reduce the building energy consumption in the winter. So from that point of view, yes, we have to be careful that we don't negate it when the climate is quite cold. However, given the fact that cities take long time to change, 30, 40, 50 years to change, what policies we put in place today will only be visible, the effects will only be visible in 2050, by which time the climate might be different.
So in this case, it's very, very important to have the simulations run from the results that we get today. So we have enough data here to calibrate a computer model using, for instance, the EnviMat tool, and that's something that has been done here. So we can use the model of a particular region or a particular part of the city here, and we can predict how this region, how this area would behave within 35, 40 years from now.
We are currently doing some work for some of the councils in the valley to do heat mapping, the traditional heat mapping of energy demand and energy supply. We are now trying to superimpose the heat island on top of the energy demand and supply to see whether the heat island itself could help reduce the demand until the climate remains cooler. Over a period of time, of course it is then possible over a period of time to see what if the climate warms, at which point heat island ceases to be a positive thing in Glasgow. And then it becomes a problem. And then you've got to see then how to manage that beyond that problem stage.
Okay. Could you tell us anything more about any future research plans? What other problems or issues you believe are important to investigate in this area?
I think we talked about it when Eduardo came back this year, yesterday as well. We probably have three broad areas in which we want to take this further. One is to develop linkages between the urban morphology's effect and the atmospheric effect. I mean, this is the part of that the last few slides that Eduardo showed. That it is, we talk about the heat island effect. There is no single heat island effect. It varies from day to day. It depends on what kind of atmospheric condition, what kind of climatic condition we get. Whether it's raining today or whether it's sunny day, the effects are big. So we need to now relate the urban morphology effect to climate effect, so that we could then better predict what are the minor changes that would happen. So if tomorrow BBC gives a prediction of tomorrow's temperature is 20, we could then say at the street level it would be 22 or maybe 19. That's very important to be able to predict at that level. That is one thing, I think. Second is also we want to link this effect, the urban heat island effect, to land cover changes, because that's what ultimately planners control. We don't have control over much other than where activities go. That's about it, the planners and urban designers. So we want to be able to come up with some relationship between what we find in terms of heat island and how planners could then use it for residential areas, for commercial areas, for shopping districts and so forth, a relationship. I think that is two. Number three is this heat mapping. We want to get closely linked this work to traditional heat mapping exercises. So far, heat mapping is simply geographically mapping heat demand to heat supply. We want to also put in the heat island as another layer on a GIS, essentially.
Okay, thank you very much. Here is one more question. Let's look at this question and show to our viewers. It is from Alistair Henry, who is saying, climate change is expected to make the west of Scotland rainfall to increase very significantly, particularly in winter. Does the analysis of the heat island for Glasgow need to take this into account in some respect?
Yes. In fact, there is a lot of evidence that cities' climate itself, the urban heat island itself, leads to more rainfall. So this will only superimpose itself on the global climate change. So we could then expect built-up areas of the valley would probably have more rain than what the climate change would predict. Because in effect, the city is like a mountain. It forces the warm air to rise up, so causes more rain to fall. So yes, this is something that we need to take into account. There are, as you know, as I'm sure Alistair himself would know, the UK CIP Climate Impact Programme has predictions for the region, West of Scotland. But it does not take into account the urban effect. This is the global warming effect. This undoubtedly is very difficult. I think it's slightly beyond our capabilities. We will then need to link to meteorologists who could then take the local effect into their models to predict what superimposition would happen from urban areas.
Could we conclude from this that more moderate climate is really not in cities, but around the cities because of the urban heat island effect? If urban heat island attracts more rain, then the changes in the weather are more often in cities.
Yes, that is true. I mean, which is a problem actually. As more and more people now move into cities, more and more climate variation. I think more than climate change, I think climate variation is a bigger problem. If the climate warms, we will, as you correctly asked earlier, isn't it? We will adapt over a period of time. We will adapt. But if it varies, today is extremely hot, tomorrow is very cold. It's very difficult to adapt. So that would, and if that happens more and more in cities, which will make our adaptive capacity even less. And in places where already cities are weaker, the governance is not so strong, it will be even greater problem. So yes, that is true.
Okay. Well, thank you very much. We don't have any more questions from our online viewers, and I would like now to thank you both for your presentation and to thank our online viewers for their questions. And before we close, I would just like to say to our online viewers that the next event that we are organizing is a conference entitled Mass Matters in Low Carbon Building Design. And this conference will take place on 3rd September from 9 to 4 o'clock at Heriot-Watt University in Edinburgh. This is a live conference and there will be no online transmission. Just a brief summary about this conference. Thermal mass in buildings acts in a number of different ways that are potentially very important in creating the comfortable, safe, and affordable low-carbon buildings that we need for an unpredictable future. This conference is designed to inform attendees about why, how, when, and where mass is important in design. Examples will be given of how it has been successfully incorporated into new and traditional low-carbon buildings, and approaches and tools will be described that can be used by designers to optimally place and utilize mass in buildings. The conference is suitable for building engineers, architects, developers, regulators, house owners, renewable energy professionals, construction industry professionals, and manufacturers. Please access our conference webpage to book places and for other more detailed information on topics and speakers, on sponsorship opportunities and exhibition opportunities. We look forward to welcoming you at our forthcoming events, and I would like to thank you for watching this webinar. Thank you.